So Terraform, as the name suggests, is a cloud agnostic infrastructure orchestrator, right? So Terraform was started somewhere in 2014, right? And the idea was that you should have a method or a tool, right, which is cloud agnostic, right? So that any of the skills that we have, right, while building a particular cloud platform, we can use those same skills in any other cloud platform. At the same time, right, there are also possibilities that you could have a multi-cloud environment, and Terraform is the perfect tool to orchestrate infrastructure in such a scenario. Now it's an open source tool which was developed by HashiCorp. In 2014, I think the first version was 0.1, and they supported AWS and DigitalOcean. And at that point in time, Terraform was it didn't support a lot. But over a period, and it wasn't very popular either, right? But over a period of time, it's garnered a lot of support, and there are a lot of contributors as well on GitHub. Today, Terraform is currently on version 1.3.3, right? And and supports around 130 cloud providers. One of the most important things about Terraform is that it has a very declarative syntax. So what do I mean by declarative syntax? Like, let's say you want to write a bubble sort algorithm, right? So if you actually go into the details on how you're going to write it, right, with the if loops and the conditions, right? So then that kind of syntax is imperative syntax, right? Declarative syntax means that you just tell the tool, in this case Terraform, that I want to run bubble sort, right, and give it certain parameters, and it'll just do it. It's very human readable, right? It's very much like JSON, right? But the language is called HCL, HashiCorp configuration language. And it was primarily built, excuse me, it was primarily built to provision infrastructure, but in some cases it can do deployments as well. So I really want to talk about how you can set up Terraform on your machine. Now, the Terraform itself, it's just an executable. If you go to the HashiCorp website and you say you want to download Terraform, it's just a single executable, an exe or for a Windows and just a simple executable for a Mac. Now, while you could probably do it on your own, copy it to your folder and set up the path, there's a tool called tfenv, right? And you can install this using Homebrew, right? And once you install it, right, let me just show you. So once you install it, tfenv gives you all these options, right? You can install a specific version, you can use it, you can uninstall, you can list the current installed versions, you can list the remote version. Now why is this necessary? Now, the thing about Terraform is, Terraform is improving or getting updated almost every month, right? There'll be new versions of Terraform coming in, and since Terraform is cloud agnostic, and you'll have cloud providers release new features, like let's say AWS release a new kind of resource, or Azure release a new kind of resource. So then Terraform always has to release its own API to get those implemented, right? So it's obvious that you'll have different versions. And while it is absolutely fine to keep continuously upgrading your version of Terraform, there will be obvious scenarios, right, where there might be breaking changes, right? And so you'd obviously want to keep yourself safe. So using tfenv, you can have more than one version of Terraform installed on your machine, and you can choose which version you want to run. So it's just simple as this. If I say tfenv install, and I'll say actually, I'm not sure how many versions I'll just click on list. I just have 2 versions on my machine. So if I say tfenv use 1.3.0. So earlier versions of tfenv, we had to first install and then use. But with the newer versions, you can just click use, it'll install it for you and set up everything, right? So now I'll switch back to the version that I was using. That's 1.3.3, and there you go. That's it, right? It's pretty easy. So this is on the Mac. On Windows, it's a little different. So on Windows, TFNV is not supported, but instead, so I've added a link here. So you can you'll have to install Chocolatey, and using Chocolatey, which is a package manager for Windows, you can install multiple versions of Terraform, right? But then if you want to switch it, so I've added a link over here. This gentleman over here, he's added in the article that he's written, he explains how to use a batch file to do the switching. So I'll just show you. I've already configured it on my virtual machine. So right. So because I'm using the version switcher, I don't have to use Terraform. Instead, the batch file has added a shorthand for us. So you use TF instead. And so if I say TF switch and I say 1.3 point, it'll just switch over. So this is sort of a workaround. It's not perfect, but you can get the same sort of feel on Windows as you have with the Mac, right? So that's just the reason why I thought I'll just highlight this. Okay. So next, I want to talk about the different phases of Terraform. So in Terraform, um, the Terraform command itself, I mean, it has more than 4 commands, right? But I'd like to concentrate on these 4: init, plan, apply, and destroy. So as I said, Terraform supports different providers. So whenever we want to start off or run Terraform, we'll first have to initialize that provider within that particular folder, and that's what the init command does. It downloads any resource or any configuration that Terraform needs for this particular provider to get initialized. I'll explain. I mean, I'll once I go to the demos, right? This will probably make more sense. But I just wanted to highlight this over here. The next part is plan. So what Terraform does is based on the Terraform configuration that we have, right? It creates a plan, right? It says, okay, so let's say I want to create an Azure web app, right? So then it'll take the configuration I have and create a plan saying that, okay, based on the configuration that you provided to me, it looks like that you want to create one web app and you want to create a virtual network, one subnet, and so on. So that's what the plan does. As an output of the plan, a file called tf plan will get created, right? And we use that file within the apply command to apply that configuration into the particular cloud provider that we have. The destroy command, what it basically does is it destroys any existing infrastructure that Terraform has orchestrated. So how does Terraform work? So um, unlike like cloud formations or ARM templates, right, which have direct access to state within each of the cloud provider, Terraform doesn't have that, out of the box. So what I'm trying to say is, so let's say uh, day one, right, we decide, okay, I want to start off with Terraform. I want to build something in the cloud. So I write up my Terraform scripts to um, add a virtual network and add a small EC2 machine in AWS, right? So when I do a Terraform plan, what Terraform will do is it will take the information that I've provided and it'll go to AWS and say, okay, it doesn't look like any of these resources have been created. So these resources need to be created. And then it says, okay, fine, create these resources. And once it creates these resources, it creates this state file. Now, the state file is important because any future changes to your infrastructure um, is done by comparing the state file. So if I add a new subnet to my virtual network, right, the state file will say, okay, so you already have a virtual network. You've already have one subnet. You're adding a new one, which means that the only change that you will have to do is add an additional subnet. And that's what the state is used for. It's used to compare the existing state of infrastructure in the cloud with the new changes that you've asked Terraform to orchestrate. So I, I want to start to get into demos directly. So let me just open. I'm using. I think it's stuck. Um, I'm using IntelliJ uh, primarily because it's free. And because along with IntelliJ, you get a plugin for Terraform, which preferences plugins. Yep. So again, this is also free. You can download it and give it a shot. And the nice thing about this is that it adds IntelliSense to it. I've tried this with Visual Studio Code as well, but it didn't quite work for me. You know, you have plugins for HCL in Visual Studio Code as well, but this works just great. So if I just have the cursor over here and do command space, it'll show me all of these options. So you say if I want to create a resource, and it'll say, right, what kind of Azure resource I want to create. So that's a little bit about the IDE. So I've got a few examples over here for Azure. The first one is just like static files. I'm writing everything within a single file. So so whenever you want to start a Terraform project, right? So there are three things that we always need to start off with. One is we need to define the version of Terraform that you want to use. And the kind of provider that we want to use and the provider version that you want to use. So over here, I'm saying that well, I'm not specifying a version for Terraform. I can, but I'm not doing it over here because I'm using the latest one. What I'm saying is the required providers are Azure, right? And the source is HashiCorp Azure, and the version is 3.28. There are different options for versions that I can select. Now, as I said, new updates keep coming up, right? And it's always better that we have control over the versions of the cloud providers Terraform is using. This is just so that, right, we don't run into an instance where we just our CI/CD script is running and we didn't specify any specific version check, and a new version came in and there were breaking changes and our deployment fails. So it's always a good practice, right, to have to restrict the version to a certain level. Now that depends on how you want to do it, right? I generally use this option over here, this tilde and arrows, right? So this means that it will increment any patch versions for this. So it'll go to 3.28.1, 2, 3. So if there are new patch, if there are new bugs in this version, right, it'll keep on updating it, which is fine. The other option I have is I set the minimum and maximum version. Right, I say the version should be greater than this, but it should be less than 2.99. The other option is, this is very open, and it says that as long as the version is greater than 2.99, right, I'm fine. And the last option is I say that you restrict it to a single version. I say I just want it to be this version, right? So this is more about the version settings. Now the next one important file that we have to add, it's the provider file. Now we already mentioned the provider that we want over here as Azure. Now, in order for Terraform to connect to the specific cloud provider that we have, it will have to have some sort of authentication that has to be done. So within Azure, what we're doing here is we're using a service principal. So I'll just quickly go over the concept. So what we do is within the Active Directory, I create an app registration for Terraform, right? I can just click on new registration and create an app. Once this app gets created, what we do is we go into the subscription. Excuse me. You guys can see it, right? You can go into subscription, go to access control. So, and then you can assign it a role. I've assigned the role contributor for Terraform, just so that, I mean, it doesn't have to be contributor. You can restrict it even further. But in my case, I just wanted to create any kind of resource. So for me, contributor works. That's the second part. The last part is setting up a client secret. So you click on that particular app that you've created, go to certificates and secrets, and then you can create a new client secret. So the one I've created now will expire today, but yeah, you can have client secrets with longer expirations. Now, once we've got all that information, we can set up our provider authentication over here. We have the subscription ID. Now the subscription ID will be, you can get it from your subscription. That's, sorry, subscriptions. Yeah, you have your subscription ID over here. And this is the client secret that I was talking about. And the client ID is the ID for your app registration. So if I go back, go home, Active Directory, go to app registrations, go to Terraform, and here you have an application on your client ID. That's the one. And then you have your tenant ID. That's the ID of your Azure Active Directory. So with that information, Terraform can now log in into Azure and create resources for you. So we got two. We got a provider. We've got the version, and the third one is the actual infrastructure that we want to create. Most of the code that you see over here, it seems all seems a bit daunting, but as I said, there are a couple of things. The first thing is you have IntelliSense, right? The second thing is you need to have some cloud understanding. You need to understand how you'd create resources in Azure. Terraform is just a tool, right, to create those resources, but you need to have some understanding of the cloud itself. So, like for example, in Azure, we need to create a resource group before we can create any particular resource. So that's what we're doing over here. We're creating a resource group in Australia Southeast, and the name is Sydney Modern Apps. And then what we're doing is we're creating a virtual network, and we have this particular address space for that. We're saying the virtual network has to be within this particular. It has to be at this location and this resource group. Then I'm creating a subnet. Again, the subnet will be within this particular virtual network that I'm creating. And I have an address prefix for this as well. And then I'm creating a network interface, a public NIC. So what I'm trying to do here is I want to create a virtual machine which has a public IP address. And so this network interface is used to provide a public IP address for my virtual machine. And the last resource over here is the virtual machine itself. I'm giving it an admin username and password. I'm setting the location. I'm giving it the name, giving it a name. I'm setting the network interface IDs, setting the resource group name, and setting the size. So this is all standard stuff. There's nothing specific about it. So what I'm going to do now is I'm going to try and run this. All right. Right. So one of the first things that I said was the init command, right? So I'm just going to say Terraform init. And as you can see, what Terraform is doing now is it's identified that that we've got Azure. So what it's doing is installing the Azure provider, right? It's also created a log. So there's also something called as a backend. I'll explain the backend a little later. It also creates a log file, right? So basically, Terraform is careful in a sense. What it tries to do is it tries to make sure that no two processes are trying to execute the same set of infrastructure at the same time, right? So it creates a log file locally, and it says that as long as only one instance of Terraform can execute and run this, right? And now it says, yeah, it's been successfully initialized. So I'll start off with the next one. So the next command is Terraform plan. There you go. Done a lot. All right. So it says that use the selected projects to generate the following execution plan. Resource actions are indicated with the following symbols. Create. So it says that, okay, based on what you've given me, it looks like I just need to create. There are no existing, there's no existing infrastructure uh, within the context of the files that you've given me. Right. So I need to add 5, 0 to change, 0 to destroy. Now, there's a note at the end. So you didn't use the out option to save this plan, so Terraform can't guarantee exactly if you run Terraform apply now. So usually what we want to do is we want to save the plan that Terraform created. So in order to save it, we use this parameter out, minus out, equal to tf plan. And it doesn't have to be tf plan. I just like the name tf plan, but it could be any name. I'm just going to run this again so that it creates that. Wait for it to do it. Okay, cool. All right. So there's also a few things that I want to show you over here. So the TF plan file is created. Now, this is not, you can't, this is a binary file. You can't read it using a text editor. But there are a few other things that you can read over here. So there's the Terraform lock. And there's a Terraform provider. This is also, sorry, this is also not machine readable. But it's important to note that as soon as you do an init, a .terraform folder will be created, and the log file gets created. Once you create a plan, the TF plan file gets created. Now, what we actually want to do is we want to run this. So I'm going to say Terraform apply TF plan. All right, it's starting to create all the resources. Still creating, and it's done. We can quickly go to Azure. I'll open Azure. I should have a new resource group. Yeah, I have a new resource group called Sydney Modern Apps. Yeah, and I have a virtual network, and a disk, and a network interface. Excuse me. Yep, and here's the, for a second, I thought the VM didn't get created. Okay, so then here's the VM. Yeah, and we're all good. It's Linux Ubuntu standard B1L, right? So it's all good. So what I'm going to do now is I'm going to destroy this. So I'm going to say Terraform destroy. So if you just say destroy, Terraform will ask me a question. to confirm, right? The other option is, and as we continue the demo, I'll probably use that, uh, is to use the option auto approve equal to true. Yep, there you go. Do you really want to destroy all the resources? Blah blah blah. There's no undo, only yes will accept. So I'll just press yes for now. Type yes for now, and yeah, the destruction takes a bit of time, so I'll let it finish. While it finishes, we'll go to the next the next demo, right? So in here, what we had done is we had all our resources within a single file, which is fine. There's actually nothing wrong with that. But we also like we put all of these values hard coded over here. Now there might be a scenario wherein we might want to like reuse the location name elsewhere, right? So if you want to reuse a location name elsewhere, you have a concept called locals in Terraform, wherein you can have a local variable, right? When this local variable can be used locally within this file. So instead of saying Australia Southeast over here, I'll just say local dot dot um, resource location, and I can say local dot resource group name. Now, the syntax for this is simple. Anything I define, so it's like a key value pair. So I just define locals with open and close curly braces, and then I just define my key value pairs over here, whatever I want, and then I can use them as variables throughout one file. So it's like the scope is limited to one file. The second thing that I want to talk about is like um variables which have a scope of the entire folder, right? So these are those variables. So you have, so instead of so what I've done over here is I've moved almost all the values that we had over there into variables. So the provider earlier had values, so now all of them are in variables over here. So the client secret, the subscription ID, the client ID, tenant ID, all of that. Now, variables have different types. So there are different types of variables in Terraform. You have I'll just let IntelliSense do the job for me. So you have bool, number, string, tuple, map, list, any object, and set. Set is not actually a type, but it's more of trying to set up an object or try to set up a map. So I'll go through the bool. I mean, bool, number, and string. These are more or less self-explanatory. Um, we don't have to explicitly talk about them. Now, if you don't specify, you don't need to specify the type for all of the variables, because based on what you've given over here, Terraform will be able to infer it. This is a string, so Terraform knows it's a string. If it's a number, so like for example, I could say right? So test num will be of type number. The descriptions that I've written over here, they're just for documentation or just for understanding, right? And it's a good practice as well, right? So you can have a look at the description, and that'll you or anyone else who's maintaining the code, it'll make sense. Okay, so this is what the description, this is what the variable is being used for. Now those were the basic type of variables. Now the next ones are a little more complicated. So this is the not might map type of variable. So this basically has a key value pair. So you have keys and you have values. So the map type is string, so you can use only string values over here. If you can use, again, you can use a number or a boolean as well. Again, it'll be then you can use only numbers and booleans in here. The next type is list. So list, as the name suggests, it's just a list. I'm just creating a string list here, right? You can add one or more strings. There's no way to limit the size of the string. You can add as many number of elements you want in there. Then the next one is tuple, right? So tuple is an interesting one. This is like a mixed list, right? I can have more values over here, and it'll just keep on. So this tuple is number comma string. So I just have the date as 25 and October, but I can have more types. I can even have lists in here. So I can say tuple number string list of string, and then so on and so forth, right? Now, one of the things that you have to remember is when you're using these complex types, like map or list or tuple, it is necessary to specify the kind of uh, type that's being kind of simple type that we're going to use over here, like string, bool, or number, right? It's smart that we mention that. Without that, Terraform will give you an error. It's as simple as if you leave this over here, and if I try to run the specify the element type, leave that. Okay, so that was about variables, and once we define the variables over here, we can use them throughout the folder. We can just use them. There's nothing stopping us from doing it. Now, the next thing I wanted to talk about was outputs. Now, one of the things that Terraform does is when you create a resource, these resources will have certain attributes. Excuse me, certain attributes associated with them. And these are attributes that get associated with them after the resource gets created. So let's say I created a network interface. So once the network interface gets created, it will have an IP address associated with it. So I've added outputs over here. So what we'll do is we just run this, right? So when oh, okay, and those values are destroyed. So just here. I'll have to go through the same commands again, Terraform init, and then Terraform plan, and then Terraform apply. Okay, cool. Yep. So apart from, so if you notice in the plan now, apart from showing the usual, that is all the resources that it's expecting to create, what it's also done is it's added these outputs as well. It's added network details and VM details, right? So once I run apply, so let's run apply. Wait for it to finish. Ooh. Right. So why do you think it's saying this? It looks like the resource group is not found. There's a slight difference as to why you get there's a slight difference from what we did earlier and what we did now. If you notice here, I've moved like I have multiple files now instead of a single file. I have one file for network, one file for resource group, one file for the VM, right? And what I've done here is within the resource group, I just say I'm using the strings from the variables, right? And within the network, what I've done is I'm using the strings from the variables itself. I mean, I could have used the resource group, but I didn't. Instead, I used the strings from the variables. Now, if you go back over here, right? If you come over here, if you see that we're using Azure RM resource group location. So what Terraform does is when more than one resources are created and we add references to resources over here, so Terraform creates a sort of a dependency, right? And that dependency is implicit because we've added the source as a parameter to the next one, right? But as you know, the location and name, they're just strings, right? We just pick them up from the where did we pick it up from? I think we picked it up from the variables over here. Yeah, we picked up some variables. So what's stopping us from adding this as a string? Nothing, right? But what happens at that time is, so since there is no direct correlation, right? Terraform will then try to create all the resources in parallel. It'll try to create the resource group. It'll try to create the network all at the same time. And now what happens is when the network, excuse me, is getting created, it says you're asking me to create a network for this resource group, but this resource group hasn't been created yet, right? And that's the reason why it's throwing error. So in order to, I mean, there might be certain situations, where we might have one particular resource which is created in a maybe a separate project, right? And we might want to have dependencies, or there's also another concept called modules, which I can probably talk about. But there are also certain scenarios wherein we even though in this case we have an explicit dependencies, there are resources both in Azure and AWS wherein the providers say that you have to create this resource first before you create this, even though there is no direct correlation between two of them. So when you have to add explicit correlation, you need to add the depends keyword. So it goes something like this: just say depends on, and then you give the name of the resource. So I'll say it depends on Azure RM resource group, my resource group. So now what will happen is Terraform understands, okay, fine. Okay, so since there's a dependency over here, I'll first create the resource group and then I'll create all the dependencies later. Now you might ask, so then don't the others need any kind of dependency over there? So let's just do a quick check, right? So we're creating the VNet first. The VNet, you need the VNet if I want to create a subnet. You need the subnet if I want to create a public network interface. And if I want to create a VM, I need a public network interface. So the rest of the dependencies are inherently are already added, right? The only dependency that was missing was for the virtual network. That was missing was between the virtual network and the source group. So now let's just clear this. Let's try again. Sorry. Oops. Sorry. Wrong command. Cool. All right. So it looks like it created it. So now let's apply it. Now it should create the resource group first, and then go on to the virtual network. Oh, all right. So why do you think this happened? So what happened the first time was I didn't have the dependency and I went ahead and ran it. So the resource group got created, right? And it went through fine, but the rest of the stuff didn't get created. Now, even though the resource group got created, it wasn't updated in the state because Terraform didn't finish executing it, right? So in scenarios like this, you'll have to destroy whatever you might have to do one of the two, right? A, if the resource group has already been added to the state, you can first see it. So let's do another command. This is called Terraform show. This will show me what the state has. Right now, the state has nothing, right? So there are certain scenarios where, because you miss to add a command where the resources and the resources get created in the cloud inadvertently. In those cases, you'll have to manually go in and delete the resources. So what I'm going to do now is I'm going to manually go in and delete the resource group. Okay. Is it just me or is it getting a bit stuffy here? All right, cool. So I'll apply. Source group gets created, and then it goes to the VNet. Then it goes to the subnet. Then it goes to the NIC and the VM. All right. Cool. Okay. So what's also done over here is as I added a couple of outputs over here. Excuse me. So it's showing you everything that all the attributes of the. I think this is the public network interface. What is its ID? What is its IP configuration? So on and so forth. Now VM details are not being shown because I've set the VM details to sensitive. And it might be possible, right, that you might have some sensitive information that you don't, sorry, where's the output? You don't want it to be shown, but in this case, I mean, it doesn't matter. You guys can see the network interface details for this. But now, this is a good example to see updates. So the only thing I've changed here is I've changed the output parameter. Ouch. Looks like there's certain details of the VM that we can't actually show, and Terraform is not letting me do that. So let's try again. Okay, so this time, if I go back to the top, it says the changes made, blah, blah, which may have affected this plan. And it says the only thing that has changed is here, right? So it says these things will get changed. And if I do an apply now, cool. So it's shown me all the network interfaces that are associated over there. Yeah, but it actually didn't add any resources because I actually didn't make any changes in the resources itself. The only change I made was in the output, so the output has been updated. So the reason, I mean, the whole idea behind this is Terraform supports delta changes to your infrastructure. So let's say over a period of time you want to scale your infrastructure, sorry, scale your infrastructure, or you want to make changes to it. So let's say you want to add a new network interface, you want to upgrade the size of your VM, you want to add additional hard disks, etc., etc. Right? So every time that happens, an update will happen. So the existing infrastructure will not be changed; it'll just get updated. Now, again, this depends upon each cloud resource, right? Because there are certain conditions, right? For example, if you're trying to change, I'm thinking of an example. Uh, okay, so in let's say in the web app in Azure Web, if you're trying to change the type from uh, shared to standard, right? So those kind of changes would require recreating the entire resource itself, right? And these rules are not defined by Terraform. These rules are defined by the cloud provider. So if it says that if you're trying to upgrade from shared to standard or shared to premium, right? At that point in time, the existing infrastructure will have to be deleted and recreated. So going to the last demo here in Azure, and that's the last part is loading this from. So we first looked at having static files. That is, everything is hard coded and written in one. But usually when you do CI/CD, most of the information would be configurable. You'll have a dev infrastructure project, and you'll have you'll have single infrastructure project with dev and prod stages, right? So you'll have dev configuration values, and you'll have staging configuration values, and you'll have prod configuration values. So it doesn't make sense that you hard code everything, right? Although in certain cases it's fine if I have the same address prefix, but I can't possibly have the same resource group for my 3 different environments. I'll probably have to have different resource groups or different subscriptions. It depends on how we want to set them up. So this isn't very scalable for me, right? In the second, what we do is we took a step further, right? We moved them out from one place, but we just put them in another place, right? So storing them in variables itself also is not a very scalable option. So the third option that Terraform gives you is um, uh, empty variables, right? So if you look over here, I still have the same variables. I mean, I'm still using some of them over here, right? I've not changed all of them, right? But at least 4 of them: the client secret, the subscription, the client ID, the tenant ID, the admin password, all of them are blank, right? So what Terraform supports is, right, you can use environment variables to load them. So the environment variables should be in the format tf_var_variable name, right? So I'm using PowerShell here to set these environment variables, right? And then what I'm doing is, once these environment variables are set, I'm just using a simple PowerShell script to execute them. There's no difference between this and the previous one. I'll just have to destroy this. So I'm just going to destroy this. Now, since I've given the auto approve equal to true, Terraform won't ask me a question this time. It'll just go ahead and destroy the infrastructure. So while this is getting deleted, um, I'll just quickly go through this. Nothing fancy. All I'm doing is I'm getting the path of the current script, and then once I get the path of the current script, I get the full name of the directory, and then I'm using combine to combine the name of the directory and Terraform. So the command will be executed from the scripts file. So all it does is it changes the location from the scripts file to the Terraform directory, and then does init, plan, and apply. Still destroying it. Might take about a minute, two. Um, do you guys have any questions you want to ask? No?
Much to switch between, say, Azure and AWS?
From an authentication perspective, yes, but otherwise, it's more or less the same. I'll just come to it once. All right, cool. All right, we'll move to the last demo. All right, so first what I'll do is I'll execute this load environment variables partial script. For this, I need to open partial. So let me do that. And scripts. All right, and right, and I'll just execute deploy. So it does the same thing. It's initializing. Yep, it did the plan. Yep, and it's creating it. Well, I'll just let this get created. Um, so that's all for the Azure demo. I'll just quickly do the AWS one. Um, the probably the only difference between, I mean, the couple of differences between this and the Azure demo is the version. And here the version, we need to make sure we're selecting AWS, not Azure, right? And the second one again is in the provider. So in Azure Provider, we had to do authentication using uh, the tenant ID, the client ID, the client secret, and subscription ID. In AWS, instead, we use a profile. So what I've done here is, right, under AWS, I've created a user called Terraform, right? And for that user, I've created a um, um, access key ID, a key ID, and a key secret, right? Uh, Also, I've given this guy administrator access. Again, this is a little too much, yeah, but it works for the demo. So the way this works is, um, once you create the security credentials, you need to save them in the uh, right. Uh, right. So can you see this? Better. All right. So the way this works is, you create this AWS configuration file on your machine, right? You'll have to do the same thing on any VM you intend to deploy this. You give it a profile name and you set the profile key ID and the access secret and the sorry, the ID and the secret, right? You save them over here. Once you do that, you give it a name. So this is the profile name for that particular user. And what I do over here is I set the profile name. So what the AWS provider will do is it'll go into that particular for it knows that the key and ID is saved over there. It'll go in there and fetch it. And the second thing I need to mention is the region. So the region here that I want to deploy this is AP Southeast. Nothing fancy over here. I'm just creating an EC2 instance with an instance type and an instance name. All the variables are being set from code over here. So it's a test instance. It's a EC2 instance type is T2 micro, and this is the AMI. AMI is AWS machine image. I think I'm using an Ubuntu one. So I'm just going to run this. So if I go yeah, I'll just start with Terraform init. Yeah, as you can see over here, it's downloading the AWS provider. I'll run the plan. This might take a bit. Oh, it's done. All right. We'll just go to the console. If I go into EC2 instances. All right. Okay. Sorry. This is North Virginia. I need to go to Sydney. Need to go to EC2. There's one instance running. And this is our T2 micro. T2 micro. And there was a tag that we set, test instance. So yeah, so that's all I had to talk about today. I guess there are, I mean, from here, what I'd suggest is just try to start off creating a product of your own, going to Azure or AWS and do it. It's pretty simple. Once you get a little familiar with it, then probably you can go into more advanced topics. There is a concept called modules. So one of the things that Terraform does is it always, if you noticed, I always have to run it in the main directory. So when I say main directory, I mean like the AWS demo where all the files are there. So if I add a subfolder, excuse me, if I add another folder over here and I have more Terraform files, .tf files, Terraform will absolutely ignore them, right? So if you want to make sure that Terraform includes them, we'll have to create something called as a module, right? Wherein we tell Terraform that, so it'll be something like this. So I say module, and I give it a name. I'll just call this test. And if I create a folder over here, and I'll call it my module. Oops. All right. So I can say source my module, right? Right. So at this point in time, what Terraform will do is he'll go in and he'll execute the things that are there as well. Now, it um, it makes sense to use modules when you want to like reuse things. Let's say you have a big project, a big infrastructure project wherein you have to use your network stuff somewhere, right? Or let's say I'll give you an example. So let's say you're building infrastructure for, let's say, a payment platform, or so then you'll have to create virtual networks, subnets, um, event hubs, event bridges, queues, databases, right? You might also have to add load balancers, and then usually whenever I build a project, the concept is that you try to keep the infrastructure close to the code. In the sense, if you have an API project, you'll try to make sure that the infrastructure for the API project is within the same repository. But for infrastructure such as virtual network, you won't have any code associated with it. So all the infrastructure of that kind would probably fall into a separate repository itself, right? But as the time grows, the repository will, I mean, if we follow this pattern over here, the repository will go extremely huge, and maintenance becomes a bit of an issue because there are so many files you have to browse through and see what's what, right? Using modules, you can arrange them better, right? You can add conditions like you might not want to run certain modules. I mean, it depends on requirement, but you might not want to run certain modules in certain stages. So let's say I have a certification provider, right? A private certification provider. They are extremely costly, but let's say I have a requirement to have a private certification provider. I wouldn't want to run that in development. I'd only want to run that in production. So using modules, I can add conditions saying that if the stage is this, if I'm running it in a stage where a variable is test or a variable is dev, then skip it. If it's prod, then run it. So modules are usually used for these kind of things when you want to do some kind of arrangement, or arrangement is the wrong word, where you want to um, associate common infrastructure together, right? And reuse. So if you want to reuse a module somewhere else, right, within your bigger project, probably makes sense to have a module over there as well. Yeah. So that's it. I'm open to any questions if you guys have any. Sure.
So is there that maybe visualizing what your infrastructure looks like now? Thing where just sort of rely on the cloud that
Yeah.
you're working on.
Yeah, not in Terraform. So AWS has, but even for AWS, right? If you build using CloudFormations, then that CloudFormation file can then be converted into a visual representation in AWS. I am not sure if ARM templates have any of that. I don't remember because I haven't. I'll be frank. I haven't worked a lot with ARM templates. I have worked a bit with CloudFormations because I mean, unlike Terraform, right, where I can have like these multiple files and all that, CloudFormations has a limit of 512 KB or MB. I do not remember, right? And after that, you'll have to have nested the CloudFormation files, which also makes it complicated. In ARM templates, you can only have one file. So if you have a lot of stuff to do, file size gets really large. So visual representation is not something that Terraform supports out of the box. You'll have to use something else for that. I'm not sure if, yeah, as I said, AWS CloudFormations does that. I'm aware of it. I'm not sure of ARM.
Maybe copying them with some modifications. You have a dev test.
Yeah. Right. So I wouldn't copy. I'd probably have a single. So like the last example that we did over here within the Azure demo, the load from environment. So this is a very good example of having such a setup. Thank you so much. Yeah, so this is the perfect example for that. So yeah, I mean, if I had a project wherein, yeah, I mean, usually any infrastructure project that you have, you'll probably want to have multiple stages associated with it, and the only way to do that is by using environment variables. So you have, so what I generally do is, I mean, you could, I mean, let's take Azure for example, right? So within Azure, I can have multiple subscriptions. So let's say I have a subscription for dev, subscription for test, subscription for prod, right? So then what I would have to do is, right, so in here, these values will change for test, dev, and prod. And so using environment variables in, let's say I'm using Azure DevOps, I'll have three different libraries over there, one for dev, one for prod, one for test. And every time I do a release, I can add conditions to make sure one set of environment variables are used. And then, so I'll have a dev deployment, I'll have a test, and I have a production deployment. But usually, I mean, so if you want it to be, if you want to, like you said, separate it, right? You'd want to make sure you don't hard code anything, even for the names, right? So like, excuse me. Yeah, I think I forgot to mention that. So even for the names, so like you can do something like this, right? So let's say you want to name something, your resource group, right? So you can say, you can give a standard name for the resource group, right? And add like you can add like an environment variable. You can say dev hyphen Sydney Modern Apps, test hyphen Sydney Modern Apps, prod hyphen Sydney Modern Apps. So you'll have three different resource groups, and each of the resource group will hold like each environment's infrastructure. Right. So it depends on you how you want to like separate your infrastructure. I mean historically I've used both. I mean again, it depends on the client's requirement. You can explain to them, because for me I think, you know, having separate subscriptions makes sense, but having separate resource groups also works. Yeah, but yeah. So that would be a scripting task. That won't be a. So Terraform says I'll destroy it, I'll create it, but if you want to schedule it, you'll have to schedule that yourself, writing a script. Or we could probably have regular scripts run either in some. Okay, I'm thinking. Yeah, that's the only thing I think of. I mean, you'd probably have to have something running either on DevOps, saying that, right, trigger this once every X days or something, and then DevOps runs these release cycles. Once the release cycle completes, we can say delete this. Yeah, I can't think. Yeah, Terraform itself doesn't support any kind of scheduling.
Terraform as part of your CI/CD pipeline.
Yeah, I think you should. Because I mean, well, uh, I'd probably use Terraform along with the CLI, AWS CLI or Azure CLI, because Terraform can take you 90% there. Because like some deployments you can't do via Terraform, or you can do, but it gets a bit complicated. So I prefer ease. So you can use AWS CLI or Azure AZ CLI to get the same thing done. So you deploy it with Terraform, and then you can add a script to call AZ CLI to deploy your code. Yeah, yeah. ECS Fargate, yeah. Yeah. No. No. So okay. So yeah. So I understand what you're saying, and so let's just take this example over here, right? We just excuse me, created a resource. Now Terraform is intended to be idempotent in the sense you can run it 1,000 times, right? Right. But as long as you have not made any change to it, it's not going to do anything. So sorry. Yeah. Yeah. So sorry. Yeah, I added this. Let me just remove that my module. Yeah, see, it says there are no changes. Your infrastructure matches the configuration. If I run the plan again, there's nothing for us to do. So it's very good in the sense because, but the thing is, you have to your state file has to be saved somewhere. So I've not talked about this over here. So there's a concept of backend, right? And I think if we let's show it somewhere here, there you go. There's a concept called backend. So backend, I mean, so the state file is extremely important in Terraform. And what we can do is, let me just, you see this state file? This is state, Terraform TF state. So if you open this, this is for AWS. I opened it because it's a smaller one. Um, it says the resources, right? Managed AWS instance, blah blah. It says this is the AMI, so it's created where what the availability zone is, the CPU core count, threads, etc. Everything, right? So do we have the same thing over here? I deleted it. That's why it's not here. Right? But basically this, right? So this state file is extremely important, and you'll have to save it somewhere. So Terraform provides options to save state file in each provider. So in Azure, so in AWS, you can store it, save it in S3, and it's a part of. So if you're supposed to code it, it'll come something like. So sorry, in the provider. Hmm. S3, okay. And then you'll have to give the access key, you'll have to give the excuse me, the bucket and all that information. So basically what happens is once you've specified this, then when you run Terraform, it'll upload it into the S3 bucket. Now, this sort of creates a need of having a pre deployment step. So the very first time you're starting, you see you want Terraform on your project, the very first project would have to be an initialization project. What this initialization project is, it creates this bucket, the bucket where you're going to store your S3 file, and that the state for that particular those two resources, you can't save that anywhere. So you will have to save that. But then after that, any other resources you create, they'll get saved within that S3 bucket. So once it's there in the S3 bucket, then you run it, it'll use the same thing. Even if you run it 100 times, if there are no changes in the state, um, Terraform won't execute anything. So we used Terraform before because I didn't mention DynamoDB. So we used Terraform, have you? Okay, okay. Yes. Yeah. Yeah, you can't. You can't get. Yeah. Yeah. Well, so if you go and okay, so okay, so since you raised that, I'll just talk about locking as well. So one of the things that if you guys want to listen to it. So there's a log file. There's this log file that's mentioned, right? So what Terraform does is once you store your state in a backend, in a remote backend, what happens is there's a possibility that, let's say, I'm running it and you're also running it, right? And if both of us run at the same time, then it would cause like weird issues because both of us were trying to provision the same infrastructure. So what Terraform does is it uses DynamoDB to create a lock on that state file. So and it's very random. It's like first come first serve. So when two people are running it, if the first command that reaches AWS, right, and locks that file, that's the person whose commands will run. The other person will be kicked out. So there is, I mean, it's a good thing, right? Because with that file, with that record in DynamoDB, it encrypts your state file, right? And you only using that can you decrypt it. If you delete that record, your state file is useless. You cannot recover it again. So that's very important. Um, because if you delete your state file, S3 will have backups of it. You can still restore it from backup, but unless you have like some sort of backup for DynamoDB, you won't get your file back. And the only way to do that is you'll have to delete the file from S3. You can delete the .terraform as well, but deleting that will not help. You'll have to delete the file from S3 and then redo your entire state. Yeah. Yeah.
What needs to do some work.
Yeah, it's just like Flutter or Xamarin, wherein there is a little bit of time before they can come up. But I think both the AWS and Azure provider, they have options for using cloud formations. I think yes, yeah, they no, not I think I know. I'm just searching for the resource. Yeah, there you go, cloud formation stack. So if you, I mean, what you could possibly do is you could use cloud formations to run that during that time, and you can still maintain your sources with Terraform. And once the once it actually comes through, Terraform has an option to move, a new option to move it. So so you have this command for moved, right? You can say from one resource to another. So, so what you could possibly do is you first create the resource using the CloudFormation stack and keep it while as long as the Terraform update hasn't come in. Once the Terraform update comes in, you can create a new resource for the same sorry, you can create a new file and write the code for that resource, and then you can say moved from this resource to this resource, and then what Terraform will do is it will make sure that it references the resource that's created in AWS with the new code that you've written, and it'll ignore this. So after a couple of runs, you can actually remove this. Yeah. Any other questions? Right.
Thank you very much, Madhav. Awesome presentation. We'll probably do one more Sydney Modern Apps this year, end of year finale, towards the end of November, start of December. Subject yet. Let you know. via the usual channels. Thank you very much for coming.